This is my first video on antiderivatives, and as you can see, it's an introduction. So for our introduction, it says if f prime of x equals 2x, what is f of x? So we want to know what the original function is who has a derivative of 2x, okay? Well, there's two things here. One is that I'm going to show you how to find an antiderivative, but secondly, we're going to talk about a more efficient way to ask this question. So the way that mathematicians ask this question is that they use what's called an integral symbol. It looks like a stretched out S. Whatever function they want to find the antiderivative of, they put here, and then at the end of the question, like you have a question mark, is the dx. Okay, what that dx is it's again kind of like the end of our question, and it also tells us what letter we're talking about. We're talking about the letter x. If this was a t, this would be dt. If this was a q, this would be dq. Okay, now typically we play with x's. All right, so from here on out, whenever I see this integral symbol, I'm going to read it the integral of 2x dx. And what it's asking is what function has this as its derivative? Okay, well, if we think about power rule, if I had something like the original function was an x, we know its derivative is 1. Okay, so it's not, this didn't come from an x. Okay, if my original was x squared, then my derivative would be 2x. Oh, okay. But x squared is not my entire answer. And the reason why x squared isn't my entire answer is how do I know this is just x squared? What if it was x squared plus 17? This has the derivative of 2x. What if this was x squared minus 7? This also has the derivative of 2x. So what we do when we're finding integrals, these are called indefinite integrals, because we add a plus c to cover our butts in case there was originally a constant that when I took the derivative, it went to 0. Okay. Now, this first video is just an introduction about notation. So this is called the integral symbol. We want to find the antiderivative, so what function has this as its derivative? And this dx is the end of our question mark. When we find our answer, we're going to put a plus c on the end. All right, the next video is going to talk about the specific rules that we're going to use.